welcome to my channel Girlshood. I'm Shiza and today I'm going to teach you acid, bases and salts, which is the chapter 7. So please don't forget to subscribe, like and click the bell icon if you're new, and so that you will get all the notifications from my channel. And comment down your doubts whatever you are having, so I'll clarify it immediately. Next, so let's start with its introduction. We use in our daily life a large number of substances such as lemon, tamarind, common salt, sugar and vinegar. Do they have the same taste? No, they all does not have same taste. Even you have I think tasted many things. Lemon juice, orange juice, vinegar, curd, amla. They all sour differently. You find that some of them taste sour, bitter, sweet and some salty. Curd, lemon juice, orange juice and vinegar taste sour. These substances taste sour because they contain acids. The chemical nature of such substances is acidic. The word acidic comes from the Latin word acera, which means sour. The acids in these substances are natural acids. What about baking soda? Okay, over here I'm gonna explain what about baking soda. Over here you can see baking soda. Baking soda does not taste sour. It tastes how bitter. Now whatever substance tastes bitter, now it's not a sour taste, so it's not a acid. It tastes bitter, so it is termed as bases. If you even apply the baking soda solution between your fingers, you'll feel soapy. So there are two things, that if it is bitter and soapy, that is termed as bases. Now another, special type of substances are used to test whether a substance is acidic or basic. These substances are known as indicators. Examples: turmeric, litmus paper, china rose petals or gudhal, etc. are some of the natural occurring indicators. We can find this in nature. Litmus is made up of lichens. Turmeric is there at everyone's home. Okay, so you can even try this experiment of turmeric. Add some turmeric into H2O or water in a tumbler, then just stir it. You will find that it is in yellow color. Then take another glass, add again turmeric into water, and then add some little surf or soap. You can add, it will change to red. As it is a base, turmeric will change to red. As it is an acid, it will remain the same, that is yellow. Now over here properties, you can take a screenshot or you can write down if you feel difficulty in it. Acids are electrolytes, bases are also electrolytes. Acids sour taste, bases taste bitter. Next, bases turn litmus red, acids turn litmus red, bases turn litmus blue. Now this acids, now for this exam easy way, I'm just gonna say you that ABR. In base acids, blue litmus will change to red, ABR. In bases, red litmus will change to blue, BRB. Next, react with metals to form H2 gas, slippery feel. Next, over here vinegar, examples are vinegar, milk, soda, apples and citrus fruits. Over bases, examples are ammonia, lye, antacid, baking soda. Lye is a metal used to make soap, and antacid is used in digestion or neopeptine, which helps our stomach to be get free from any indigestion. Oh, next, this is a pH scale. On this only we measure water, acids and bases. If anything moves to its left side, it is acidic. If anything moves to right side, it is basic in nature. Now over in pH scale, 7 is the neutral number. In 7, the milk and the water comes as it is neutral. H2, even we call a water as H2O. Now on pH scale there are many. On 12 you can see at the right side that is bleach. Now it is a basic. Next, blood. Blood is 7.4. Okay, it comes between 7 and 8 blood. You know, right? Blood. What I'm asking, everyone know. So 7.4 blood is. Then after that, tomato juice, that is 4. Lemon, that is 2. And battery, that is 1. And next after that, that is stomach. Stomach, that also come under 2. And then after that, this is completed. Then H plus VE, H minus VE, OH plus VE, OH minus VE. Okay. So next after that is power of H is equals to pH scale. Next after that, acids can be classified as natural acid or organic acid, synthesized in or inorganic acid. Next, natural acids obtained in natural substances. Synthesized acid prepared synthetically in labs. Example HCl, sulfuric acid and nitric acid. Sulfuric acid is the queen of acids. Next, acids can be also clarified on the basis of strength, strong acid and weak acid. Strong acids are corrosive in nature, can cause burn on the skin. Example hydrochloric acid, sulfuric acid. Weak acids are mild in nature, do not cause burns on the skin. Example oxalic acid, acetic acid. Next, after that, I will say you an example. Now I am gonna say you an example of hibiscus, that is also known as China rose, that is a natural indicator. So over here so in this tumbler it will change to light pink. Okay, so it will change to light pink when we add the China rose or the hibiscus in the tumbler. Now I'm gonna take the another tumbler or the test tube and one more. Yeah, wait a second. Okay, so over here we got total 3 tumblers. In the first tumbler I have added the hibiscus or the China rose, so it changes into pale light pink. Now in another, the same over here also, that is the hibiscus. Over here also it's I have added this 3 also hibiscus, this hibiscus plus water. So 3 of them also change into pink. Now in this pink, this is there, right? Pink hibiscus solution or China rose solution. In that, if we add acid, what color will it change? Any guesses? Wait a second. You guess till that time. I will just check this. So if we add hibiscus into hibiscus water, it is an indicator, or China rose, if we add, which color will it change? Can anyone say? Okay, so in acid it will change to in acid it will change to dark pink. Okay, this is acid. This is acid. Next, over here I am gonna add in this tumbler a base, that is shampoo also you can add, or else even you can add soda water. Any base you can add. Now if we add base, to which color will it change? It changes to green color. See, so it changes to green color. Now from this we understand that in hibiscus or else in China rose, if we add any acid it changes to dark pink, and if we add any base it changes to green. This is another experiment apart from turmeric. Okay, so let's get back to our PDF. Now, properties of acids. Acids so taste, soluble in water, conduct electricity, corrosive in nature, can be stored in plastic or glass containers only. Over here, why only is why I told only. Why? Because over here, if we keep any, as you heard that acids are corrosive in nature. Now, if I keep in any metal, example, this is a metal. I kept in a metal that was acids. Okay. I kept an acid. This much acid is there, okay? Whole is acid. You think, example I am giving, this is acid. Is acid. Okay? It is acid. Now, if we add acid, what will happen to the metal? Can anyone say? This metal will get spoiled as it is corrosive in nature. As this acid is corrosive in nature, the metal will get spoiled, and it inside that whole part will be there. It will become black in color, and it will be just very spoiled bottle. Now it can't be used after adding any acid, and sometimes from this acid the bottle can even just get break if it is made up of even metal. Next, can't store in metals. Metals react with acid, as I showed the example. Examples of acids: orange juice, lemon juice or lime juice or lemon juice, that is citric acid; vinegar, acetic acid; aspirin, salicylic acid; yogurt, lactic acid; Coca-Cola, phosphoric acid; toilet bowl cleaner, sulfuric acid; bathroom cleaner, muriatic acid; wine, tartaric acid and or malic acid; vitamin C tablets, ascorbic acid; urine, uric acid. Okay, you all just can note down or take a screenshot. Next, after this, bases are bitter in taste. Example: baking soda, sodium bicarbonate; lime water, calcium hydroxide; soap, sodium potassium hydroxide; milk of magnesium, magnesium hydroxide. Bases can be classified as strong base, weak base. Examples of strong base: sodium hydroxide, potassium hydroxide. Examples of weak base: magnesium hydroxide, ammonium hydroxide. You just remember that in any we get in any the name we get hydroxide, you just think that those are bases. Next, properties of bases: slippery to taste, bitter to taste, conductivity. Few bases are soluble in water and are called alkalis. Few bases are not soluble in water. Next, bases. Common household bases include baking soda, as everyone nowadays using cakes; lye, that is a metal to make a soap; ammonia. Next, soap, which from which we make lye. Lye is made up of soap. We make soap from lye. And antacids, in lysine we use, or neopeptine we can say. Next, indicators. Natural indicator, they are classified into natural indicators and synthetic indicators. Natural indicators examples are litmus paper, turmeric, china rose and cabbage, red cabbage, etc. And synthetic indicators, phenolphthalein and methyl orange. So, over here, as I told, litmus is made up of lichens. These lichens are made up of, as the last chapter in which we learn that you have learned in your previous chapters that lichens are made up of algae and fungus. Now from this lichens we extract from many processes and adding many chemicals. We extract this litmus. Litmus paper is extracted from lichens. Next, litmus paper. The main use is to test whether the solution is acidic or alkaline. Alkaline, why we say? Why? Because over here we learned that whatever are soluble in five bases are soluble in water and are called alkalis. So that's why we call alkalis. But don't think that alkalis is new thing. What is that? What is that? Don't think that it's a base only. Over here I told red litmus paper, no change in acid, and red litmus paper to blue, it changes in alkali. Blue litmus paper, it changes in acid to blue to red, and no change in alkali. Next, turmeric. In bases, yellow turmeric solution changes to red. In acid, yellow turmeric solution remains the same. China rose, or we can say hibiscus. Light pink color solution. In acid, it changes to dark pink or magenta, as I told and even I have shown on the whiteboard. In base, it changes to green color. Synthetic indicators, that is phenolphthalein or methyl orange. Phenolphthalein is colorless. I will show you. Now phenolphthalein is colorless. Over here I'm gonna draw a tumbler again. Okay, this phenolphthalein is there. Why? Because it is colorless. It doesn't have any color. So just I'm gonna keep it plain. So the spelling of phenolphthalein I'm gonna say P. Okay, over here place is not there. I'll write over here. Back, yeah. P H E N O L P H T H A. So big spelling is this. L-E-I-N. Phenolphthalein. So big spelling. Okay, so I'm gonna write over here again. Okay, you understood? I'll write in big letters. 1 minute. P H N. No, sorry. P H E N O L P H T H A L E I N. Phenolphthalein. Not neat, right? Now I'll not repeat, just I'll write fastly so you all can copy it. Okay, then completed. Phenolphthalein. We pronounce it as phenolphthalein. It is colorless. Now this phenolphthalein. Now this phenolphthalein we have added. This phenolphthalein we have added into a tumbler now. Okay. Now this tumbler, as it is, the phenolphthalein is colorless. In acid it remains the same, colorless. In base it changes to pink. I think you all love the color pink. Pink. Okay, so over here this phenolphthalein, phenolphthalein was there. In that, if we add into that acid, it remains the same, colorless. When we add base to it, it changes to pink in color. See, over here also it's written the same. Phenolphthalein is colorless. In acid it remains same, colorless. In base it changes to pink color. Methyl orange is orange or on color. In acid it changes to red. In base it changes to yellow. Totally different it is now. Next, phenolphthalein, acid and alkali, or we can say base. Next, phenolphthalein color change. In acidic 7, I told this is the pH scale 7, it remains the same. Alkali is light pink, means it's 8. The little light, it going darker. At 14 is the highest. Okay. Now after that, this is again textbook part, no need. This is methyl orange. Over here 7 is, I told, neutral. If we go above till 14, that is 14 means acidic. Down if we go, it is, 14 is basic. Down if we go, it is acidic. These all are textbook parts. Acid bases, which is equals to salt plus water. Okay. So over here I am going to explain you again. That process you all have seen. Acid plus base gives rises to, or else give a new material, that is salt. Okay, so actually this you all have to copy down, because they can ask this. Salt plus water wait guys, acid and bases, salt plus water and plus little bit, only little of heat. Little of heat will be there in that, okay? Heat and little heat. Okay? Acid plus base is equals to salt plus water plus heat, little heat. And I will write again in small. Acid plus base is equals to salt plus water plus little bit of heat. Then this process, right, you all also copy down, this process is called as neutralization. Copy this. Neutralization. Okay. So this process is called as neutralization. Copy this. Acid plus base give rises to salt plus water plus little heat. This process is called as neutralization. Okay. Now, as I told the same, and even we can write this in like chemical form. HCl plus NaOH. Can anyone say what we say to water and salt? Do anyone know? Okay, then I will only say HCl plus NaOH gives rises to NaCl plus H2O. HCl, hydrochloric acid plus NaOH gives rises to NaCl, salt, common salt, water, H2O. Okay then, this is a formula. Next, neutralization reaction, acid base, H2O plus water or H2O plus salt. Next, HCl plus NaOH, H2O plus NaCl. Next, HNO3 plus NaOH gives rises to H2O plus NaNO3, that is also salt. We can write in many different. Too much acid produced in stomach take base substance to destroy acid, that is antacid. Neutralization. Antacid treated with rubbing soda, sodium hydrogen carbonate. Soil treatment treated with quicklime calcium oxide or slag lime calcium hydroxide. If the soil is basic, organic matter compost is added. Organic matter releases acid which neutralizes the basic nature of the soil. Factory wastes. It is acidic and neutralized by adding acidic or basic substances, slag lime calcium hydroxide. Okay, then this is completed. Now after that I am going to show you one more. There are many chemical names. I will give you as homework. You just comment down what are the answers of it. RNA, first one, RNA, second one, HCl, third one, DNA, fourth one, oh my goodness, yeah, fourth one, NaCl, fifth one, whatever I have teased you from that only I'm giving, I'm thinking and giving, NaOH, NaOH, and then sixth one, let me think, guys. What else I can give? Okay, H2O, easy one. H2O, okay. RNA, HCl, DNA, NaCl, NaOH, and H2O. Okay, so please copy these down. This is your homework. So from this we have completed a chapter and we have come to the end of acids, bases, and salts. So I hope that you have learnt it very nicely, and even I think many of you don't have doubts. If you have doubts, you can comment down below. As I told, I will just immediately respond. So but many of the children have these doubts. When I have just teached like normally, then I got a doubt from one student, that is from lichens. Directly we can take lichens and go to test. Never. Okay, as like you all I think also have the same doubt. If you do like that, it will not show any different. Why? Because if you like, you write on the paper, take the pencil and directly take the wood and write. Why to use paper then? Yes, like that only this also. Lichens can never be directly used. Okay, so guys, we have come to the end of this chapter. Thank you, and for whatever this I got in comments, that to just teach this chapter. Okay, so in next class, whatever you will comment, I will just teach that next chapter. Okay, so thank you guys. Bye guys, have a nice day, and please don't forget to subscribe and like and comment down below. Thank you guys. Bye guys, have a beautiful day.